Okay, let's get started with this review. According to the DuPont Global Automotive Color Popularity Report, 23% of all cars manufactured in the current year are white. Random sample of cars parked in the long-term parking at Philadelphia Airport reveals that 19% of the cars were white. Which statement is true? So the population, the population is according to I guess this is all current year cars in the United States, I'm assuming, is the population. They took a sample of cars from the Philadelphia airport. So this comes from the population, so it's a parameter. So 23% is not a statistic. 23% is not the population. That's a parameter about the population. 19% is definitely not that. So 23%, so one of these, 23% is a parameter. And 19% comes from the sample, which is the cars from the Philadelphia airport. So it's a statistic. So 19%, so it's got to be B. To reduce the variability for a random sample, which is good, we like less variability, so you have to use a larger sample. I mean, that one's almost easy. You get more precise results is the words we're looking for there. A large population, 46% of U.S. households have a two-car garage. Random sample of 100 households gives you a sample proportion, which is the following expression represents more than half the household sample with a two-car garage. So let's just remember what Z is. Z is basically like the value minus the mean over the standard deviation. So in this case, let's see, I guess the mean is the mean proportion, which is weird. We call it a mean, but it's a mean proportion. It's actually a proportion is 0.46. Standard deviation, I don't think we know, but there's a formula for that, right, for a proportion. So it's P times 1 minus P, so 0.46 times 1 minus that. I just prefer to write 0.54. I'm not sure how they did it. Over 100 was the sample size. And we want more than half, so half would be 0.5. We want more than that, so greater than or equal to, I think would be so Z is greater than or equal to, so what's the probability that looks correct there? Again, we're just plopping the formula for standard deviation there in the denominator, figure out which one's which. The inequality was greater than, so we're going greater than there. This one's on 2 pages here. Hopefully we can just kind of see it. Oops. Okay, so an automobile insurer has found that repair claims have a mean of 920. Man, they've gone up. And a standard deviation of 870. So there could be a lot smaller. Suppose that you were to choose many simple random samples of 100 claims and calculate the average claim amount. Which of the following are the mean and standard deviation? So the mean, so this is talking about a sampling distribution here. So that means every possible sample of size 100. So the mean should be the same as the population mean. It should be 920. So I'm leaning towards A or B. Standard deviation is going to be a formula, right? These are means, right? So the standard deviation of the population was 870 divided by the square root of n, which is square root of 100. So I think that'd be 80 divided by 10 here, so that would be 87. So I think it'd be A. The CLT refers to which of the following characteristics? Okay, so I'll just kind of read through them. Some of these might be close. I don't know which one's going to be. Regardless of the shape of the population's distribution, I like that. The sample distribution of the sample mean is from a sufficiently large, in other words, more than 30 or more, will be approximately normal. I'm pretty sure it's A, but sometimes the wording is just tricky here. Regardless of the shape of the population, the standard deviation of sample mean will be, So we have to check the less than 10% condition, not the CLT for that one. So that's not a thing. Regardless of the shape, because CLT proves normality or approximately normal. Regardless of the shape of the distribution, the mean of the sample distribution will be equal to the mean of the population. That's not the CLT. So those are tempting, but not the CLT. As you select larger and larger samples, standard deviation gets smaller and smaller. That might be true, but that's not the central limit theorem. These are tempting because they're tempting. As you select larger and larger samples from a normally distributed population, the mean of the sample distribution and the sample mean gets closer. No, I think if it's a true sample distribution, it's the same as the population mean. The distribution of lifespans for gas ovens has a mean of 15 years and a standard deviation of 4.2 years. The distribution of lifespan for electric ovens has blah, blah, blah. Both distributions are moderately skewed to the right. That's fine. Suppose we select a simple random sample of 35. I like that. That's over 30. And 40. That's over 30. So by the CLT, the difference of these guys is going to be approximately normal, which is why best describes the sampling distribution. So approximately normal, I'm leaning towards here. So the mean is 1.6. I don't even have to look because all of them say mean is 1.6. So I think the mean is 1.6. That comes from subtracting the two means in the order of G minus E. Standard deviation, I think the formula is square root is from memory. I hope this is right. Let's see. So standard deviation is 4.2. So 4.2 squared over the sample size, which is 35, plus 3.7 squared over the sample size, which is 40. Let's see what we get here. So square root. I could be wrong about the formula. It's totally from memory. 4.2 squared. It's really actually good to have your formula sheet. Plus 3.7 squared over 40. So 0.92. So I think it's the first students in a local high school that participate in sports is 62%. That sounds like the mean proportion there. The school's newspaper wants to select a simple random sample at the school to survey what they do with their free time. What is the smallest sample size that satisfies the large count condition? So we need n times p to be greater than or equal to 10, right? So we know p is 0.62. So n times 0.62, I'm going to write 0.62 times n is greater than or equal to 10. Let's get our calculator out. 10 divided by 0.62. So we think n needs to be at least 16.29 for the first one. Then n times 1 minus p, so 0.38 n must be greater than or equal to 10. Let's do that one. So 10 divided by 0.38, 26. So this n must be greater than or equal to 26.32. So what's the best answer? What is the smallest sample size that satisfies? We know n has to be bigger than that, so 27 is the smallest. Which of the following variables is continuous? Yeah, that's it. Time is continuous. Number of brothers is like integers or whole numbers. Number of cars, integers, whole numbers. Number of orders received, integers, whole numbers. Yeah, that guy. Okay, so let's see. So in order for that formula to calculate standard deviation, what must we check? The sample size, so we must check 3. I don't think it has to be normal just to check standard deviation, so I think that's it. So I think it's 3 only. Okay, cereal company puts vouchers in free boxes of cereal. They claim that 20% of the boxers contain the voucher. Consumer advocate is concerned that the portion of boxes with vouchers is actually less than 20%. So he selects a random sample of 50 boxes. He finds 7 boxes with the voucher. Determine if the sample proportion 0.14 combines convincing evidence. So we're saying what P equals 0.14. That's I guess right here, or more extreme. So how many of those dots are 0.14 or less? I guess you would say. So it looks like about 22. Looking at the answers, so 22 out of 100 is 22%, which isn't that unusual, right? So is there convincing evidence? No, that's got to be it, I think. Yeah, so okay. Okay, a restaurant manager estimates that 45% of all customers would order the nightly special that came with a free dessert. Manager selects a random sample of 50 customers to survey to see if they would order the nightly special if it came with a free dessert. I'd consider it. Calculate the mean and standard deviation of the sampling distribution of p-hat. Portion of customers that answer yes to the survey. Okay, so we need to calculate the mean. Well, this is a sampling distribution, right? So, because we're taking a sample of 50 customers, every possible sample of that size. So 44% of the mean p-hat. In other words, the true population proportion is 0.45. Therefore, the mean of the sample is 0.45. Okay, so the standard deviation. Before you do standard deviation, we need less than 10%. So 50 is less than 10% of it doesn't really specify. I'm saying like monthly customers or something, or just all the customers. It's probably all the customers, I guess. It doesn't really specify that. I was looking for a timeline. But that's what you need to check before doing standard deviation. So now we plug into the formula for standard deviation. So it'd be 0.45 times 1 minus that, which is 0.55, over n, which is 50. So we type that in our calculator. So 0.45 times 0.55 all over 50. So 0.0704 or something. Justify the sampling distribution of p-hat as approximately normal. So these are proportions, single one here. So we're going to say n times p. So in this case, n would be 50 times p is 0.45. 0.45, we think that's at least 10. It is. 50 times 0.55, or 1 minus p, is also greater than 10. We think those are both true. Calculate the probability that no more than 40% of customers answered yes to the survey. So remember, we've got a normal curve here. We proved that. In the middle is the 0.45. The standard deviation is 0.07. And we're trying to get 40%, no more than that. So 40%, so this way, right? So 0.4. So you're going to do norm CF. I'm just going to do it, but norm. So I'm going to use 652. Lower bound, that's fine. Upper bound, 0.4. Mean is 0.45. Standard deviation 0.07. And you want to put the command here, norm CDF, negative infinity, comma 0, comma 0.4, comma 0.07, and put like lower, upper, mean, standard deviation. I'm getting sloppy there, but you get the idea. And this equals 0.237. So not that unusual. 23.7% of the time. Scores in a mechanical aptitude, okay, are known as skewed to the right with a national average of 400, standard deviation of 60. Maintenance manager at a large airport selects a random sample of 40 airline machinists and administrators to do the mechanical aptitude test. Afterwards, the mean score, X bar, is calculated. Describe the shape, center, and variability of the sampling distribution of X bar for samples of size n equals 40 from the population of all mechanical aptitude test takers. Include a justification for the description of your shape. So these are means, right? So to prove normality, we want to say that 60 is greater than or equal to 30. Check, we can prove that it's normal. So we know that the mean of the sampling, mean of p hat, or sorry, the mean of X bar is going to be 400. It's the same as the population mean. And standard deviation of X bar is going to be a formula. Standard deviation, 60, divided by square root of n, which is random sample of 40. Why did I say 50? Sorry, this should have been 40. So I didn't catch that. There's 40. I saw the 60. My mind went there. So there's 40. That's a 4 there. So 60 divided by square root of 40. So 9.487. The mean score of the 40 airline machinists is 425. With the probability, the random sample of 40 is 425 or greater. So we're drawing the curve. So in the middle is mean of X bar, which is 400. Standard deviation is 9.487. We want to get 425 or greater, right? So 425. So get out your calculator. So menu 652. So lower bound is 425. Upper bound is infinity, or a very big number. Mean is 400. 9.487. 0.00425. Again, you want to put the norm. See, put your work. That's our answer. Norm CDF. With the numbers plugged in and labeled lower, upper, mean, standard deviation. Is there convincing evidence? So let's look at that as our answer here. There's a 0.4% chance, yes. Why? Because 0.004 is less than 0.05%, or less than 5%, I should say. Therefore, it's unusual, and so it is. We have evidence. Okay. Many has two different routes you can take to school. The first route is the longer distance, has no traffic lights. The second route is shorter distance, but has lots of traffic lights. The amount of time it takes to get to school by the longer distance routes follow a normal distribution with a mean of 20, standard deviation 1.5. Shorter distance one has a mean of 17 and standard deviation of 6.5. Suppose we select independent random samples of 20 days. X bar 1 minus X bar 2 is the difference in the sample route. So root. So what is the shape of the sampling distribution? So for this one, these are proportions or means. These are means, right? So we want to look at sample size, I think. $20 for each route. Okay, 20 doesn't pass the CLT, so I'm like, what are we supposed to do here? Well, read closer, I did not read closer, that both of these the populations they're drawing from is a normal distribution. So even the sample sizes too, it's going to be, what is it, approximately normal. Because of why? Because the population is normal. I'll just write that. Find the mean of the sampling distribution. Okay, so the mean of the sampling distribution would be, so I'm doing x bar L minus S, right? So L is 20 minus S is 17, which is 3 minutes, I guess you'd say. Verify the 10% condition is met, calculate the standard deviation. So 10% condition is 20. It's less than 10% of all days. Not sure what the time period was, but I'm assuming it's a year or something. So that checks. Then calculate the standard deviation. So the formula for means, when it's differences, I think you add, I think there's two fractions. I think you take the standard deviation of 1.5, square it, divide by n1, which is 20, and that's a 1.5, and then 6.5, square it, divide by 20. Oops. Attention there. Plus 6.5, I think, squared over 20. Oh, 6.5, sorry, I went to I type wrong. Okay, so standard deviation is 1.49. Should be surprised that this is less than the sample of that. So this is definitely normal. The mean is 3. The standard deviation is 1.49. We're trying to find that it's the long distance is less. So it's long minus short. So if that's a smaller number minus a bigger number, that's going to be negative. So here's 0. This way. So get your calculator out, menu 652. So definitely that is still good. Upper bound is 0. Mean is 3. Standard deviation is 1.49. So 0.022. And again, show your command with the inputs there, norm CDF, etc. Use the answers. Hopefully I got those right. Looks pretty good from what I can tell. Yeah, it would be surprising. So I don't know if the question asked that and read it carefully. Should we be surprised? I didn't really answer the question. So 2.2% is less than 5%. So we have evidence to say you should be surprised. That's an unusually low number. Sorry, always answer the questions. It is good to check those answers. Sometimes we don't read things carefully. I don't.